Good day everyone. So for today, I am going to discuss about Unit 1, Limit, Functions, and Continuity. Infinite discontinuities, functions, operations, compositions, application, limits, corollary, limit of theorem of trigonometric functions, infinite discontinuities, limit at infinity, and continuity. And for Unit 2, three-step rule, derivatives of algebraic functions, chain rule, higher order derivatives, and implicit differentiation. So, before we start, we must know about its history. Modern calculus was developed in 17th century in Europe by Isaac Newton and Gottfried Wilhelm Leibniz, but elements of it appeared in ancient Greece, then in China and the Middle East, and still later again in medieval Europe and India. Johannes Kepler's work Stereometrica Dolorum formed the basis of integral calculus. Kepler developed a method, sum of radii, for calculating the area of an ellipse. The formal study of calculus brought together Cavalieris infinitesimals with calculus of finite differences developed in Europe at around the same time. Pierre de Fermat, claiming that he borrowed from Diophantus, introduced the concept of adequality, which represented equality up to an infinitesimal error term. The combination was achieved by John Wallis, Isaac Barrow, and James Gregory, the latter proving the second fundamental theorem of calculus around 1670. The product rule and chain rule, the notions of higher derivatives and Taylor series, and of analytic functions were used by Isaac Newton in an idiosyncratic notation which he applied to solve problems of mathematical physics. These ideas were arranged into a true calculus of infinitesimals by Gottfried Wilhelm Leibniz, who was originally accused of plagiarism by Newton. He is now regarded an independent inventor and contributor to calculus. The ancient period introduced some of the ideas that led to integral calculus, but does not seem to have developed these ideas in a rigorous and systematic way. Calculations of volume and area, one goal of integral calculus, can be found in the Egyptian Moscow Papyrus, 13th dynasty, 1820 BC. But the formulas are simple instructions with no indications as to method, and some of them lack of major components. From the age of Greek mathematics, Eudoxus 400 to 355 BC used the method of exhaustion. Archimedes 287 to 212 BC developed this idea, further inventing heuristics which resemble the methods of integral calculus. The method of exhaustion was later discovered independently in China by Liu Hui in the 3rd century AD in order to find the area of a circle. In 5th century AD, Zhu Gengzi, son of Zhu Chongzi, established a method that would later be called Cavalieris principle to find the volume of sphere. In the Middle East, Hassan ibn al-Haytham, Latinized as Al-Hazen, 965 C to 1040 CE, derived a formula for the sum of fourth power. He used the result to carry out what would now be called an integration of this function, where the formulae for the sums of integral square and fourth powers allowed him to calculate the volume of paraboloid. In the 14th century, Indian mathematicians gave a non-rigorous method resembling differentiation applicable to some trigonometric function. Madhava of Sangamagrama and the Kerala School of Astronomy and Mathematics thereby stated components of calculus. A complete theory encompassing these components is now well known in Western world as Taylor series or infinite series approximations in India. Today, Leibniz and Newton are usually both given credit for independently inventing and developing calculus. Newton was the first to apply calculus to general physics, and Leibniz developed much of the notation used in calculus today. The basic insights that both Newton and Leibniz provide were the laws of differentiation and integration, second and higher derivatives, and the notions of approximating polynomial series. By Newton's time, the fundamental of theorem of calculus was known. Continuity. A function f of x is said to be continuous if the following conditions are all satisfied. 1. F of a exists. The limit of f of x exists as x approaches to a. The limit of f of x equals to f of a x approaches to a. If any of the conditions 1, 2, 3 is not satisfied, then the function is said to be discontinuous at x is equals to a. When f of a exists and limit when f of a exists and limit f of x equals to a f a and x is approaches to a positive, the function f of x is said to be the right-hand continuity at x is equals to a. On the other hand, if f of a exists and limit of f of x equals to f of a and x approaches to a negative, then the f of x is said to be a left-hand continuity at x is equals to a. Example, f of x equals to x squared is continuous at x is equals to, because in applying the definition of a continuous function on f of x equals to x squared with x equals to, we have 1. f2 is equals to 2 and 4 and equals to 4. And we have a discussion video about it.
So, sa example number 1 natin, meron tayong f of x equals to x squared is continuous at x is equals to 2. So, gagawin lang natin. Number 1, equals to squared is equals to 4. Then, limit of f of x approaches to as x approaches to 2 equals limit of x squared is equals to 4 as x approaches to 2. Then limit of f of x as x approaches to 2 is equals to f2. So, ayan. Pag ang function ay continuous at x is equals to 2, isa tong continuous at sa lahat ng finite values of x. So, para sa example number 2 natin, meron tayong f of x equals 3x over x minus 5. Gaya ng ginawa natin sa example number 1, yung denominator lang yung i-focus natin. So, x minus 5 equals natin sa 0. So, pag nilipat, mababago yung sign and x is equals to positive 5. And that is our final answer. So, para sa example number 3 natin, meron tayong f of x equals to x squared plus 3 all over x squared minus 16. So, kagaya ng ginawa natin sa example number 2, di natin gagalawin yung numerator. Doon lang tayo mag-focus sa denominator. So, rewrite lang natin x squared plus 3 all over. So, lagay tayong dalawang close and open parenthesis. X minus 4, x plus 4. So, para makuha natin yung point of discontinuity, gawin lang natin yung ginawa natin sa example number 2. So, x minus 4 equals 0, x plus 4 equals 0. So, lipat natin sa kabila, mababago yung sign. So, x is equals to positive 4 and x is equals to negative 4. Ito na yung final answer.
Limits at infinity. To evaluate the limits at infinity for rational function, we divide the numerator and denominator by the highest power of x appearing in the denominator. This determines which term in the overall expression dominates the behavior of function at large values of x.
So, sa limits at infinity naman, meron tayong tinatawag na special theorem. Ito yung lim 1 over x as x approaches to infinity is equals to 0. So, malalaman nyo mamaya kung paano natin maia-apply yan. So, sa example natin, meron tayong limit of 2x squared minus x plus 3 all over 3x squared plus 5 as x approaches to infinity. So, yan. Dahil ito yung may pinakamataas na degree, ito yung gagamitin natin. So, 2x squared all over x squared minus x over x squared plus 3 over x squared all over 3x squared over x squared plus 5 over x squared. So, pagka sinimplify natin yan, magiging 2 minus 1 over x plus 3 over x squared all over 3 plus 5 over x squared. So, dito na ngayon papasok yung special theorem natin. So, dahil gagamitin natin to, makakancel na to, is equal na 0, to 0. So, ang natira na lang ay 2 and 3. So, our final answer is 2 over 3. Yan. So, sa number 2, meron naman tayong limit of 5x plus 2 all over 2x cubed minus 1 as x approaches to infinity. So, kagaya ginawa natin kanina, dahil ito yung may pinakamataas na degree, yun ulit yung gagamitin natin. So, meron tayong 5x over x cubed plus 2 over x cubed all over 2x cubed over x cubed minus 1 over x cubed. So, simplify natin. Magiging 5 over x squared plus 2 over x cubed all over 2 minus 1 over x cubed. So, pag in-apply natin yung special limit theorem, magiging 0, 0, and 0. So, 0 over 2 is equals to 0, and that is our final answer. Okay, so sa number 3, meron tayong limit of x squared plus x square root of x squared plus x minus x. So, x approaches to infinity. Para mawala yung radical sign, kailangan natin i-multiply. Square root of x squared plus x minus x multiplied by square root of x squared plus x over x squared plus x plus x. So, kuha natin is x squared plus x minus, dahil pag pinag-multiply natin yung positive and negative is negative, x squared, tapos copy natin denominator, square root of x squared plus x plus x. Simplify natin, x all over x squared, pinactor out ko lang, 1 plus 1x plus x equals x. So, pag nilabas ulit natin yung x, x 1 plus 1 over x plus x. So, dahil may kamukha ulit, labas lang ulit natin x over x, labas natin yung x. 1 plus 1 over x, magiging 1 na lang. So, para makancel ito, magiging 1 lang at 1. So, magiging 1 over square root of 1 plus 1 over x plus 1 equals, dahil gagamitin na natin dito yung special theorem, kaya magiging 0 na lang to. So, 1 over square root of 1 plus 1. Alam naman natin yung square root of 1 is equals to 1. So, magiging 1 plus 1 equals 1 over 2. And that is our final answer.
Limit of trigonometric functions. Consider the sine function fx equals sine x, where x is measured in radian. The sine function is continuous everywhere as we see in the graph above. Therefore, limit of sine x equals sine c as x approaches to c. If a is any number in the natural domain of corresponding trigonometric function, then limit of limit of sine x equals sine a as x approaches to a, limit of cos x equals cos a as x approaches to a, limit of tan x equals tan a as x approaches to a, limit of cosecant x equals cosecant A as x approaches to A. Limit of secant x equals secant A as x approaches to A. And limit of cotangent x equals cotangent A as x approaches to A. Limit of trigonometric function. If A is any number in the domain of the corresponding trigonometric function, then limit of sine x equals sine A is equals to x approaches to A. So these were I discussed later. Limit of sine x over x is equals to 1 as x approaches to 0. And limit of 1 minus cos x over x is equals to 0 as x approaches to 0. Limit of tan x over x is equals to 1 as x approaches to 0.
So, in finding the limits of trigonometric functions, ang gagawin natin ay, may example tayo dito, limit of sine x squared minus 1 over x minus 1 as x approaches to 0. So, gagawin lang natin is, substitute natin yung 0 sa x. So, 0 squared minus 1 over 0 minus 1 equals sine negative 1 over negative 1. So, pag divide natin, ang final answer natin is sine positive 1. Di siya nag-0 kaya acceptable siya. And this is our final answer. So, for number 2, we have limit of sine 5x over x as x approaches to 0. So, we have limit of sine 5x over x. Multiply natin siya sa 5 over 5. We have limit of sine 5x over yung 5 ilipat natin dito. So, magiging 5x multiplied by 5. So, x approaches to 0. So, gawin natin tong y is equals to 5x. And limit of sine y over y as y approaches to 0 multiplied by 5. As we all know that limit of sine x over x as x approaches to 0 is equals to 1. So, 1 multiplied by 5 is equals 5. And that is our final answer. So, for example number 3, we have limit of sine 2x over 5s as x approaches to 0. So, limit of sine 2x over 5x as x approaches to 0. Multiply natin sa 2. We have limit of sine 2x over, palitin natin sila. So, we have 2x multiplied by 2 over 5. X approaches to 0. So, we have y is equals to 2x. And limit of sine y over y as y approaches to 0 multiplied by 2 over 5. As we all know that limit of sine x over x is equals to 1. And this is equals to 1 multiplied by 2 over 5 is equals to 2 over 5. And that is our final answer.
So for Unit 2, we have 3-step rule. Find f x plus delta x minus f of x. Second step is find x plus delta x minus f of x over delta x. And third, evaluate limit of x plus delta x minus f of x all over delta x as delta x approaches to 0. So, how to compute for derivative?
So, dito naman sa 3-step rule, gagamit tayo ng 3-step para makuha natin yung final answer. So, ang formula natin ay step 1, fx plus delta x minus f of x. Step 2, fx plus delta x minus f of x all over delta x. And step 3, limit of fx plus delta x minus f of x all over delta x as delta x approaches to 0. So, para sa example number 2, meron tayong f of x equals x raised to 4 plus x. So, apply na natin yung 3-step rule. X plus delta x raised to 4 plus x plus delta x. Minus x raised to 4 plus delta x. So, sa case na to, mag-a-apply tayo ng Pascal triangle. So, pag i-apply natin, magiging ganito siya. X raised to 4 plus 4x cubed delta x plus 6x squared delta x squared plus 4x delta x raised to 3 plus delta x raised to 4 plus x plus delta x minus x raised to 4 minus x. So, magiging pag i-apply na natin yan, magka-cancel out tayo. Cancel. And cancel. So, ang natira na lang ay 4x cubed delta x plus 6x squared delta x squared plus 4x delta x cubed plus delta x all over delta x. So, magka-cancel na tayo. Cancel. Magiging 1 na lang. So, natira na lang ay 4x cubed plus 6x squared plus 4x plus 1. Limit of delta x approaches to 0. 4x cubed plus 6x delta x plus 4x delta x squared plus 1. 4x cubed plus 0 plus 0 plus 1 equals 4x cubed plus 1. Yan po ang ating final answer. So, for example number 1, meron tayong f of x equals to x squared. So, apply natin yung step 1, 2, and 3. Fx plus delta x minus f of x is equals to x plus delta x squared minus x squared. So, pahabain natin. X squared plus 2x delta x plus delta x squared minus x squared. Tapos, may magkamukhang cancel natin. And, natira na lang ay 2x delta x plus delta x squared. And, i-apply natin yung step number 2. Over delta x. So, cancel. Tira na lang isa. Cancel. Tira na lang ay 2x plus delta x. Apply natin to. Rule number 3. Limit of 2x plus delta x as delta x approaches to 0. 2x plus 0 equals 2x.
The operation of differentiation, or finding the derivative of a function, has the fundamental property of linearity. The operation of differentiation, or finding the derivative of a function, has the fundamental property of linearity. This property makes taking the derivative easier for functions constructed from the basic elementary functions using the operations of addition and multiplication by a constant number. The basic differentiation rules allow us to compute the derivatives of such functions without using the formal definition of the derivative. Consider these rules in more detail.
So, sa basic differentiation formulas, meron tayong iba't ibang uri ng formulas. So, number 1 is constant rule. D over dx constant is equals to 0. For example, y is equals to 5. So, dy over dx is equals to 0. Or y prime is equals to 0. dy over dx or y prime is also the same. So, the general rule is d over dx as x is equals to 1. For example, y is equals to 5 minus x. So, y prime equals 0 minus x. So, y prime is equals to negative 1. Another example, y plus 6 equals 3 plus x. Y prime plus 0 equals 0 plus 1. So, y prime is equals to 1. So, for the power rule, meron tayong d over dx x raised to n. So, n is for any exponent equals n times x n raised to n minus 1. For example, y is equals to x cubed minus 6. So, y prime is equals to 3x squared minus 0 equals 3x squared. Another example is y prime equals 4x cubed minus 3x squared plus x. So that is our final answer. So next is constant multiple rule. we have d over dx k multiplied by f of x. For example, y is equals to 5x squared minus x plus 5. Gagawin na natin yan is y prime equals 5 multiply mo siya sa 2x minus 1 plus 0. Y prime is equals to multiply 10x minus 1. And that is our final answer. Para sa ating chain rule, d over dx is f of x raised to n. For example, 5x cubed minus 3x squared raised to 5. So, we have y prime equals, labas lang natin to, 5. Dahil natin yung nasa loob, 5x cubed x squared. Labas na isa raised to 4. Multiply by derivative nito, 15 x squared minus 6x. So, we have y prime. Simplify na lang natin to. Okay. 5x cubed minus 3x squared raised to 4 multiplied by 15x squared minus 6x. So, that is our final answer since hindi natin siya pwedeng i-FOIL method.
Higher order derivatives. The process of differentiation can be applied several times in succession of leading in particular to second derivative of the f of the function f, which is just the derivative of f.
So, sa higher order derivatives, meron tayong y is equals to 3x raised to 4 minus 5x cubed plus 3x squared minus 5x minus 10. So, ang hanapin natin ay y raised to 4. So, we have y prime is equals to 3 4x squared minus 5 3x squared plus 3 times 2 plus 5 times 1. So, we have 12x cubed minus 15x squared plus 6x plus 5. Next is, so ayan na yung first derivative. Next, second derivative is 12 3x squared minus 25 times 2x plus 6 times 1 equals 36 2x minus 30x plus 6. So, ayan na yung second derivative. And for the third derivative, na tayong 36 times 2x minus 30 times 1 is 72x minus 30. So, for the final, yung y derivative, fourth derivative, meron tayong 72 times 1. And our final answer for fourth derivative is 72.
Thank you for listening and thank you for your attention.